Dear viewers, Assalamu alaikum warahmatullahi wabarakatuh. Today I am going to throw light on the chapter 8 of class 10th mathematics, that's introduction to trigonometry. First of all, we will see the literal meaning of word trigonometry. Literal meaning. Basically, the word trigonometry is composed of three Greek words, that is trigonometry. These are the three Greek words. Tri means three, gono means sides, and metry means measure. That is, trigonometry is the measurement of three sides. Measurement of three sides of a triangle. Now, the definition of the trigonometry. Definition. Trigonometry is that branch of mathematics which deals with the study of relationship between the sides and the angles of a triangle and the calculations based on them, especially trigonometric ratios. Definition, I will write it here. It is the branch of mathematics which deals with the study of relationship between the sides and the angles of a triangle, particularly the calculations based on them, particularly trigonometric ratios. So, dear students, this is the definition. It's that branch of mathematics which deals with the study of relationship between sides and the angles of a triangle and the calculations based on them, particularly trigonometric ratios. So, here comes the word trigonometric ratios. What are trigonometric ratios? So, dear students, it's necessary here to mention that at the 10th level, we only apply the trigonometry in a right-angled triangle. Right-angled triangle. So, first of all, before going through the trigonometric ratios, I would like to give you a little bit information about a right triangle. So, let's take the example of a right triangle ABC. ABC, right angled at angle B. So, a right triangle has three sides, that here AB, BC, AC. But these three sides have their particular names. That is, one's known as the hypotenuse, and another one is base, and the third one is perpendicular. So, before calculating the trigonometric ratios, we can identify the base, which side is base, which side is hypotenuse, and which side is perpendicular. So let's start from the hypotenuse. In a right triangle, hypotenuse is that side which is opposite to the right angle. So here, right angle is angle B, and the side opposed to it is AC. Therefore, in this triangle ABC, AC is the hypotenuse. So hypotenuse is defined as side opposite to the right angle. Right angle. In this triangle, we have AC as the side opposite to the right angle, that's AC is the hypotenuse. Now, base and perpendicular. Before identifying which side is base and which side is perpendicular, here in triangle ABC, the sum of the three interior angles is equal to 180 degree by the angle sum property of a triangle. So angle A plus B plus C is equal to 180 by angle sum property of a triangle. But angle A plus angle B is equal to 90 because the given triangle ABC is a right triangle right angled at angle B. Hence angle B is equal to 90 degree plus C is equal to 180. That is angle A plus C is equal to 180. This plus 90 will transfer to right hand side and become minus 90. That is A plus C is equal to 180 minus 90. That's equal to 90. So in any right triangle, the sum of these two angles excluding the right angle is equal to 90 degree. That means both of these angles will be less than 90. That is acute angles. So in any right triangle, the two angles excluding the right angle are acute angles. Acute angles. So dear students, base and perpendicular interchange their places accordingly as we change the given acute angle. Suppose in this triangle ABC, I am considering angle A as the given acute angle. So perpendicular is side opposite to given acute angle. Given means that very acute angle which we are considering, as I am considering angle A here as the given acute angle. So side opposed to given acute angle here, BC is the side opposed to given acute angle A. So BC forms the perpendicular. Now base is defined as the side adjacent to the given acute angle. Here given acute angle is A, it has two adjacent sides, one is AB and another is AC, but we have already declared AC as the hypotenuse of the given triangle. So remaining AB is the base. So base is defined as side adjacent to given acute angle. So here AB is the base. So these were the three sides, hypotenuse, base and perpendicular, on behalf of which we calculate the trigonometric ratios in a right triangle. Now trigonometric ratios. Trigonometric ratios. Basically we have 6 trigonometric ratios, that is sine, cos, tan, cosec, sec, cot. The names of these 6 trigonometric ratios was suggested by Sir John Herschel in 1813. But the names of these trigonometric ratios dates back, their origin deals with the mathematicians like Aryabhata, Muhammad ibn Musa al-Khwarizmi, Ibn al-Wafa and Ibn al-Wafa. However, the first trigonometric table was apparently compiled by Hipparchus, who is consequently known as the father of trigonometry. Hipparchus is known as the father of the trigonometry. Hipparchus was a Greek mathematician, astronomer and geographer, especially known for the incidental discovery of his precession of equinoxes. So, dear students, now sine, cos, tan, cosec, sec and cot, these are the 6 trigonometric ratios. So, how we can calculate these 6 trigonometric ratios in a right triangle? For memorizing this, I would like to give you a small trick, a small sentence, that is, some people have curly black hair to present beauty. Take the first alphabet of each word, that is S from the sum, P from the people, H from the have. Similarly, C, B, H, T, P, B. That is, sine is equal to perpendicular divided by hypotenuse. C, cos is equal to base upon hypotenuse, and T, tan is equal to perpendicular divided by base. Now, the three other ratios, that's cosec, sec, and cot. These are cosec, sec, and cot. First of all, these are the three ratios, that's sine, cos, tan. Now, cosec, sec, and cot. Cosec, sec, and cot. These three ratios are the reciprocals of first three ratios. That is, cosec is the reciprocal of sine, sec is the reciprocal of cos, and cot is the reciprocal of tan. If sine is equal to perpendicular divided by hypotenuse, then cosec is equal to hypotenuse divided by perpendicular. If cos is equal to base upon hypotenuse, then sec is equal to hypotenuse divided by base. Similarly, if tan is equal to perpendicular divided by base, then cot is equal to base upon perpendicular. Now, we'll take an example and calculate all 6 trigonometric ratios in that triangle. Suppose I will take the example of a right triangle ABC. ABC, right angled at angle B, and I will consider angle A as the given acute angle. So, when we are considering angle A as the given acute angle, then BC becomes the perpendicular as it is side opposed to the given acute angle. AB becomes the base as it is side adjacent to the given acute angle, and AC becomes the hypotenuse as it is side opposed to the right angle. Now, we have to calculate 6 trigonometric ratios, that is sine of angle A, that is sine A, cos A, tan A, cosec A, sec A, and cot A. Now, sine A. Here, sine is equal to perpendicular divided by hypotenuse. Sine is equal to perpendicular divided by hypotenuse. Here, perpendicular is BC and hypotenuse is AC. BC, perpendicular is the opposite side to the given acute angle, and AC is the hypotenuse. Now, cos A, base divided by hypotenuse. Base here is AB and hypotenuse is AC, that is adjacent side to the given acute angle divided by hypotenuse. Similarly, tan, perpendicular divided by base. Here perpendicular is BC and the base is AB, that's opposite side to the given adjacent angle, given acute angle, and adjacent side to the given acute angle. Now, cosec, sec, and cot, these are the reciprocals of the given three ratios, that sine, cos, and tan respectively. Now, we will calculate cosec A. If sine is equal to perpendicular divided by hypotenuse, then cosec is equal to hypotenuse divided by perpendicular. Here, hypotenuse is AC and the perpendicular is BC, that is hypotenuse divided by opposite side to the given acute angle. Similarly, sec A, hypotenuse divided by base. Hypotenuse here is AC and the base is AB, that is hypotenuse divided by adjacent side. Similarly, cot A, base upon perpendicular, that is here base is AB divided by perpendicular BC, that is adjacent side divided by opposite side. So, this is the process, this is the trick how we can calculate 6 trigonometric ratios in a particular triangle. But here it's necessary to mention that if we change the position of the given acute angle, suppose in the first case we consider angle A as the given acute angle. Now, in the second case, if I will consider C as the given acute angle, A, B, C, right triangle at angle B, and now I will consider C as the given acute angle. So, just reverse here. AB is the side opposed to given acute angle, so it forms the perpendicular, and BC is the adjacent side, so it forms the base, and AC is the hypotenuse. Now, calculating once again these 6 ratios in the same manner, sine A is equal to perpendicular divided by hypotenuse, or you can see here perpendicular divided by hypotenuse. Perpendicular here is AB divided by hypotenuse AC. That is opposite side to the given acute angle divided by hypotenuse. Then cos A is equal to base upon hypotenuse. That's here. Base is BC divided by hypotenuse is AC. That is adjacent side divided by hypotenuse. Now tan A. Tan A is perpendicular divided by base. That is perpendicular here is AB divided by base BC. That is opposite side divided by adjacent side. Now cosec A is equal to hypotenuse divided by perpendicular, that is AC by AB. That's hypotenuse divided by opposite side. Similarly, sec A. Sec A is equal to hypotenuse divided by base. Hypotenuse divided by base. Hypotenuse is AC and base is BC. That is hypotenuse divided by adjacent side. Cot A, perpendicular divided by base upon perpendicular. Base upon perpendicular. That's base here is BC divided by AB. So you will check out here. If we change the given acute angle, then the base and perpendicular interchange their places. When we consider angle A as the given acute angle, then BC forms the perpendicular, and when we consider C as the given acute angle, then AB forms the perpendicular. So base and perpendicular apparently change their positions accordingly if we change the given acute angle, and on that very basis the trigonometric ratios also change. Thank you. It was little information about the trigonometry, the chapter 8 of the class 10th. Thank you. Have a pleasant day.